Hi to all my brainries who are watching this video. I am thrilled to say that Brainry, an educational channel, is starting physics in 15 minutes, where concepts, derivations and numericals of 12th NCERT will be dealt in detail. To whichever coaching institute you have been registered, it hardly matters. Here you will get the base of CBSE Boards, NEET, JEE Mains and Civil Services. With the motto of no gossiping, just focusing for 15 minutes. Let's start and hope you will find the session enriching and valuable. Please don't forget to press the like button and subscribe the channel. For further queries, you may contact the given email ID. Okay, welcome to my channel. Let's begin with our today's topic of class 12 physics. The today's topic is charge and its properties. So to begin with, let's have an introduction of this particular topic, that is of electrostatics. Now what is electrostatics? Electrostatics is the branch of physics which deals with the study of forces, fields and potentials arising from static charges. This word electricity is derived from the Greek word electron, which means ember. So first of all, the electrostatic, how it was observed by Greek philosopher Thales of Miletus. When he observed that ember is rubbed with wool, it attracts the light objects. So we are having one activity using comb and paper to show how that electrostatics was observed, that we can have a charged comb and the pieces of paper. Now when this charged comb is brought near the pieces of the paper, it is observed that the pieces of paper get attracted towards the comb. It is just because of the static electricity. Now let's see, there is another activity which you can have using the plastic scale and the paper bits, in which we have to take a plastic scale, and if it is a charged one and if it is brought near pieces of paper, the pieces of papers get attracted towards it. It is again because of the static electrostatics. Now further, what is the application of electrostats that we have learned just the introduction. So it is used in the electrostatics loudspeaker, in flash connection of chimneys, in Xerox copying machine. So now next, what we are having, the electric charge. The new topic will be the basic topic that we have to start is the electric charge. Now mind it, the charge is a scalar physical quantity that is associated with matter, due to which it produces and experiences electrical and magnetic effects. That is our concern in this particular 12th class. In all the coming part 1 book, we will be dealing with the electrical and magnetic effects. Now, an obvious question comes to mind: what is the origin of charge? The origin of charge, or the cause of charging, is the actual transfer of electrons from one material to another. Now mind it, the key word here is the actual transfer of electrons. Now what is meant by this actual transfer of electrons? Let us see. If we are having a neutral body, in neutral body we know that the number of electrons and number of protons are always equal. But when this neutral body changes to a positively charged body, how it can become a positively charged body? It is just by donating the number of electrons. So by donating, what we can have, number of electrons will always be less than the number of electrons. Thus a neutral body can become a positively charged. So keep this in mind. Whenever the electrons are donated, the body becomes positively charged. Now how this neutral body can become a negatively charged body? It can become a negatively charged body by accepting the electrons. So for this negatively charged body, mind it, the number of electrons will always be greater than the number of protons. Thus we have seen the two types of the charges. What are they? One is positive and the other one is negative. So a neutral body can become a positively charged body, or it can become a negatively charged body. Now the other consequences that is related with the charge is called again as the mass. Now what happens to the mass of a body? If we are having a neutral body of mass m, and when it becomes a positively charged body, what will happen? By donating the electrons, it has become a positively charged body. So what will happen? Naturally, now its mass will be, new mass will be m dash, which will always be less than the original mass of a neutral body. Now another case, if the same neutral body, let us suppose it gets converted to it becomes a negatively charged body. Now we know that how a body can become a negatively charged, by accepting the electrons. Now by accepting the electrons, since electrons are accompanied by masses, so this negatively charged body, its new mass will become m dash, which will always be greater than the mass of the original neutral body. So keep this in mind. Whenever a neutral body becomes a positively charged, its mass is always lesser than the original mass, and when a neutral body becomes a negatively charged body, its mass always becomes a greater than the original mass. Now next, our topic will be the methods of charging. Now there are the three methods of charging. What are they? First is rubbing, second is charging by conduction, and third is charging by induction. So let us first concentrate on each of them one by one. So first we will be having rubbing. So what is rubbing? Rubbing is basically the charging by friction. So in rubbing, what we have to take? We have to take one glass rod and one silk cloth. When these two things are rubbed against each other, mind it, they are in physical contact and they are rubbing against each other. So what we will observe is that this glass rod will become positively charged and the silk cloth will become a negatively charged. Now the obvious question comes into mind, why this becomes positively charged? Because the rod would have transferred some of the electrons to the silk cloth. Keep this in mind, whenever the electrons are transferred from the glass rod to the silk cloth, it becomes positively charged, and when the silk will gets negatively charged because it has gained certain electrons from the electrons given by the rod. Similarly, if we rub an animal fur against the plastic rod, what we will notice is that animal fur will gain the positive charge and the plastic rod will gain the negative charge. Now you can answer this particular question, why animal fur becomes positively charged? Because it has donated or it has transferred some of its electrons to the plastic rod. Thus, the plastic rod which accepts the electrons becomes negatively charged, and animal fur which has donated the electrons becomes positively charged. Now, the explanation of this particular static electricity is the electron theory of electrification. What this theory explains, that electricity developed on bodies when two suitable bodies are rubbed with each other is called as the frictional electricity. Mind it, here the key word is that two suitable bodies are rubbed with each other, that is called as the static electricity. Whenever the two static bodies are rubbed with each other, this is the static electricity. Now in order to electrify a neutral body, the neutral body can have the excess of charge or it can be the deficit of the charges. Now, whenever what we can do, whenever a body is being charged positively, that is by losing some of its electrons, and a body can become charged negatively by gaining some of the electrons. So what is the key statement here? A body becomes positively charged by losing some of its electrons, and a body can become a negatively charged by gaining some of the electrons. So this is called as the electron theory of electrification. Now, next it is observed that whenever two glass rods are rubbed with a wool or a silk cloth are brought close to each other, they repel each other. Why is it so? Because both the glass rods have developed same kind of the charge. So it has been observed that they start repelling each other. Now similarly, when we take the two plastic rods rubbed with cat's fur, they again repel each other. Why is it so? Because their two plastic rods develop the same kind of the charge. But it is observed that when a glass rod and a plastic rod are brought close to each other, they too shows the attraction. Why is it so? Because they too are oppositely charged. So based on this particular observation, the conclusion drawn is that the like charges repel and unlike charges attract each other. This is how we can show the repulsion, and this is the attraction part. There is another way that like charges repel, two positive charges will repel and two negative charges will repel. Similarly, the opposite charges, that is one positive and one negative, will attract each other. Next, the second method is charging by induction. Now what happens in charging by induction? We have to take the two metallic spheres A and B brought close to each other. Now we have to bring a charged rod. If we want to charge the two spheres, we have to bring a charged rod which is already positively charged. Because of this positively charged rod, what will happen? The free electrons in the sphere are attracted towards the rod. Mind it, here what will happen? The free electrons of the sphere A will attracted towards because of this positive charge, and similarly the positive charges of B get accumulated on the rear side of its rear side. So what this is called as the method of induction of charges, and it happens almost instantly. Thus accumulated charges remain on the surface. Next, what we have to do, if the two spheres are just being separated out, then what we will notice is that the sphere A will still having negative charge and the sphere B is still having a positive charge. Now if we remove this plastic rod, this charged rod, what we will notice is that the charges on the spheres rearrange themselves, and on further separation what we notice is that the charges get uniformly distributed over them. So in this process what we have noticed is that metal spheres will each be equal and oppositely charged. Keep this in mind. This will be your key statement. What is the key statement? Metal spheres, they will by induction, by the method of induction, they can be equally and oppositely charged. This question can be asked, how we can charge the two metal spheres equally and oppositely charged. This is possible only by the method of induction. So now let's have one knowledge test. Now what the knowledge test says is, How can you charge a metal sphere positively without touching it? Mind it, here the key word is positively. So in order to charge a sphere positively, what we have to do? We have to take one uncharged sphere, that is a isolated sphere. Now in order to charge this positively, we have to bring this negatively charged rod near it, so that the positive charges of this sphere get attracted towards this particular rod and negative charge get accumulated on the other side. When we ground this, all the negative charges will be grounded over in this particular direction, and the positive charges, again there will be the redistribution. So all this you have to explain in words. So this is how you can explain in detail how we can charge a metal sphere positively. Now the similar question that can be asked on this particular pattern is how a metal sphere can be charged negatively. Mind it, here the keyword is negatively. So in order to charge a sphere negatively, we have to bring a positively charged rod. We have to bring a positively charged near it, so this sphere will develop the negative charge. So mind it, by the method of induction, always the opposite charges that get developed on the isolated body. Next question is, describe how two metal spheres can be oppositely charged by induction. Now this question I have explained earlier in the form of article in the previous slide. So I think now you all will be able to solve it. Go for it. Now the next and the last method of charging is charging by conduction. Now what's the difference between this conduction and induction is that here we have to touch that two objects without rubbing. So there the two objects are in contact with each other, but we are not rubbing it. Mind it, the key word here is just they are in touch with each other. And in induction they were not in touch. There we were having the without touching them. So here what we notice is that when a charged body is brought in contact with an uncharged conductor, charge flows from the charged body to the uncharged body. This is the key statement over here. The charge will always flows from charged body to the uncharged body. See how this happens? If we have a charged body which is positively charged, this positive charge resides on the outer surface, and we are having another uncharged body held at a separation. But now if the two bodies bring in contact, what we notice is that there is a redistribution of the charges, and now when the two spheres get separated, both the bodies become positively charged. So mind it, in case of a conduction, the body can be charged with the same sign. Keep this in mind. The body can be charged with the same sign, but in induction the bodies are charged with the opposite sign, opposite nature of charges. Next, let us come to the next article, unit and dimensional formula. The SI unit of charge is coulomb, which is denoted by the symbol C. The CGS unit of charge is ESU, which is read as electrostatic unit. The dimensional formula of QA is equals to A into T. Next is point charge. Now this point charge name will be coming frequently in the chapter, so let us it's worth mentioning over here that what is a point charge? It's whose spatial size is negligible as compared to other distances, that is whose dimensions are negligible as compared to the other distances. Now let's come on to the general properties of the charge. There are various properties of the charge, so let us go for them. First is charge is a scalar quantity, charge is transferable, charge is always associated with the mass, charge is conserved, charge is invariance, charge produces electric and magnetic field, charges resides on the outer surface of the conductor, and the charge is quantized. Mind it, these all are the general properties. Now let us go for the basic properties of the charges that will be asked in the board. So if only three properties are being asked, so you have to mention these three basic properties of the charges. Let us see what are they. First is the additivity of the charges. The point charges are scalars. Mind it, the charges are always scalars. That means they are not having any direction, only the magnitude, and they can be added algebraically. What is meant by added algebraically? If your body is having number of charges Q1, Q2, Q3 are the point charges, then again here that is point charges. We will be referring to the point charges always because their dimension are very, very small or negligible. So the total charge on the body will become Q1 plus Q2 plus Q3 plus Qn. Charges have no direction but can be positive or negative. Let us see an example of this additivity of the charge. So we are having a one question check. A total charge on a system containing 4 charges. What are they? Minus 3 microcoulomb, 2 microcoulomb, 4 microcoulomb and minus 5 microcoulomb. So the total charge on the body will be what? The algebraic sum. That is, these numerical values are added with the help of the sign only. So the total charge on the body will become minus 2 microcoulomb. That is, the net charge on the body is negative. I hope this would be clear to you. So the next property is the basic property is the conservation of charges. Now the meaning of conservation is clear to all, that nothing is being added or nothing can be deleted, only the things is that transferred. So the total charge in an isolated system is always conserved, that is constant. We cannot add or we cannot remove. Only in an isolated system the charges get transferred from one body to another, but the net charge of the system remains the same. So during rubbing, basically what happens? No new charges are being created, only there is a redistribution of the charges. Now next, third property is the quantization of charges. Now this term will be new to all of you, those who are the beginner of the 12th class. So what is the quantization? That is, the charge is always represented in the form of Q equals to NE. Here this is the formula for the quantization of charges, Q equals to NE, where Q is the total amount of charge, N is the integral integer, and E is the charge on a basic elementary particle, that is electron. So the charge on an electron is 1.621 into 10 to the power minus 19 coulomb. This is called as the quantization of charge. Now what is the cause of quantization? The cause of quantization is that during rubbing only an integral number of electrons can be transferred. Keep that, this is the key statement, only an integral number of electrons can be transferred. It means that either 1, 2, 3 or 4 number of electrons, or this is the integral number the electrons can be transferred, not in fraction, that is 1 by 2, half of the electron, 3 by 2 of the electron, 4 by 5 of the electrons will never be get transferred. That is what is meant by the quantization of charge. That means whenever the electrons are being transferred, they are always transferred in an integral multiple of E. Now quantization is usually ignored at macroscopic level, because at that point charges are taken to be continuous. Now what is meant by macroscopic level? That means at large level the charges are so continuous that this integral concept can be ignored, that is quantization of charge can be ignored and they can be treated as continuous. Now next what we have, it is 1 microcoulomb is equals to 10 to the power minus 6 coulomb. Now let's have one knowledge test based on this quantization. So what the knowledge test is having for us, how many electrons constitute 1 coulomb of charge? So here the key word is 1 coulomb of charge. So number of electrons present in 1 coulomb of charge, how we can compute? By using the formula Q equals to NE. In this particular formula we have to put the various magnitude, that is the given question Q equals to 1 coulomb. We have to compute the number of electrons for 1 coulomb. So value of Q will become 1 coulomb. Then electronic charge is 1.6 into 10 to the power minus 19 coulomb. So on substituting these particular values in this particular given formula, we will get, and so on solving we will get N equals to 6.25 into 10 to the power 18. See how many number of electrons, so huge, large quantity of electrons are present in only 1 coulomb of charge. So at this particular stage the quantization of charge can be ignored and it becomes a continuous quantity. That is what is meant by this. Now the next question is, why can one ignore quantization of electric charge when dealing with macroscopic, that is the large scale charges? Now what is the reason behind that? Because at macroscopic level one deals with the charges that are enormous compared to the magnitude of the charge E. Just now I have shown you in 1 coulomb of charge we are dealing with 10 to the power 18 electrons. So it is such a huge amount that at macroscopic level we are having an enormous or a large number of electrons, so that we can ignore, so that the charges can increase or decrease only in the units of E. Thus at macroscopic level the quantization has no practical consequences and can be ignored. Automatically it becomes continuous, so we can ignore the quantization of the charge. Whereas at microscopic level, where we are dealing with only few tens or hundreds of electrons, the quantization of the charge cannot be ignored. We have to keep on counting the number of electrons. This is all about what is meant by the negligence of the quantization of a charge at a macroscopic level. That's all for the today's video. Hope you would have enjoyed this video. And in this video, what we have seen is that introductory part, the static electricity, the methods of charging and the basic properties of the charging. Now in the upcoming video, keep on staying tuned and we will be having lots of information related to the Coulomb's law. Thank you all.